Let me repeat that. Okay, so 100 centimeter cube of water is heated by burning of a sample of ethanol. Heat released by the combustion is 10.5 kilojoules. What's the maximum increase in the temperature of water? Just as a revision. So you must understand how this concept works. Okay, as I said, we are not just here to answer the question and finish it up. No, we are doing a revision at the same time. So you must remember there is a copper beaker, all right? A copper beaker is there. So this is your copper beaker. All right, in the copper beaker, we have put in 100 centimeter cube of water, 100 centimeter cube of water. All right, below the copper, we have what we call the flame. All right, from the oil lamp, use an oil lamp. All right, just a simple fast sketch I'm doing. This is the oil. Okay, so this oil actually is not oil, this is ethanol. So this is the ethanol inside there. So the wick, all right, it sucks in the ethanol and then the ethanol is burned here. And the concept here is we want to find the amount of heat released by ethanol, but we do not have any other method. The method we have here is, of course, I did not draw the tripod stand and all that, just to give you the concept. The heat that is released during the burning of the ethanol, we expect everything to be absorbed by water. That's the concept. The heat that is released by ethanol, by the burning of the ethanol, we expect the water to absorb it completely. All right? That's how it works. Of course, we know it will not be completely because we know there will be heat loss. That's why definitely there are error in this experiment. So the error, one of the error is heat loss to the surrounding. Okay, so knowing that there will be heat loss, we try to improvise our experiment. In other words, reduce whatever errors we have to increase the accuracy of the experiment. So that is why we have certain precautionary method. One of the precautionary method is, of course, we use a copper beaker. We use a copper beaker. Why? Because what's the concept again? Heat has to be absorbed. So in order for heat to be absorbed, this material must have high thermal conductivity. So copper, this is a copper beaker. A copper beaker has high thermal conductivity. So I just put a high thermal conductivity. So what's the advantage of having a high thermal conductivity? It will be able to absorb maximum whatever heat that is released. Number two, we do not want any space here. We do not want any space here. So the flame must be touching the copper beaker, almost touching the copper beaker. The flame must be making contact. So we need good thermal contact. Good thermal contact. All right. That is why we remove the tripod. We remove the what you call the wire gauze. We do not want the wire gauze because if you have the wire gauze, the flame will make contact with the wire gauze, will heat up the wire gauze. That's wastage of heat energy. Then only the heat will go into the water. So whatever we can, we remove. We may give a direct thermal contact between the flame and the copper beaker. These are the concepts that you should have absorbed from here. So, as I said, okay, now let's come back to this. So, knowing this idea, where is the heat energy? Heat energy of ethanol. Ethanol is the one we want to find this first heat energy, but it's here. So we go back to our physics. Physics says Q is equals to mc ether. This is your 10 kilojoule. Point number one, when you use this equation, you must remember all the units must be in joules. So you are purposely given 10.5 kilojoules by the examiner to see whether you change it or convert it to joules. All right, so 10.5 kilojoule must become 10,500 joules. Your mass, all right, is 100 grams because water is very unique. It has a density of 1 gram per centimeter cube. Because many of you do not understand why we take it as 100. So I'm telling you, because the density of water is 1 gram per centimeter cube. What does that mean? This means every 1 centimeter cube of water has a mass of 1 gram. As a mass of 1 gram. So 100 centimeter cube plus 100 grams. Your C is given as 4.2. Now you calculate your theta. So your concept is well understood. Okay, the concept is well understood. Just don't solve the question, but understand the concept behind it. All right. So now I leave it for your calculators to calculate this, and you should get the answer as 25 degrees Celsius.